Hello and welcome to this webinar. Today we're going to be looking at model exports and what are some of the best practices when working with BIM. Well, before I do that, here's a bit of background about myself and the company I work for. So my name's Asan Raja, I'm a technical engineer. I work for a company called Glodon plus MagiCAD. We're a leading global construction company. Glodon Group delivers world-class products under Glodon and MagiCAD brands. As you can see on this map, we have offices all over the world. We have our headquarters for Glodon in Beijing. We have 50 branches in China. We have a branch in Hong Kong, Thailand, Malaysia, Philippines, Singapore, Indonesia. Aside from that, for MagiCAD, we have our office in Finland, which is our HQ, UK, Sweden, Germany, Italy, as well as Russia. Now, on to the main topic today. As it says here, BIM models are issued at varying stages and via different modeling styles and export settings. These variables can affect the quality of your quantity export. Now, the advice that we'll be offering here can be considered universal, so it's not just limited for use in our platform for quantity takeoff, but consider it knowledge which will help develop your BIM understanding. So in this document we look at common issues and offer advice on avoiding them and dealing with them should you encounter it. Before we start, here's a bit of background, some of the jargons or terminology, so anyone who's new to BIM or just wants a little bit of refresher is aware of it. The first one is Revit model. You may have heard of it, you may be working with one. However, as you can see here, a model is a suffix with .rvt, so if you receive a file it should have .rvt, which means it's been created using Autodesk Revit. It's one of the most popular BIM design tools. Another one is IFC model, a model which has .ifc. So a file, if you receive it, should have .ifc there. It can be exported and imported from most BIM software. It's open standard, allowing for software to pass data easily. So they're the two most popular ones, Revit and IFC. Export. When saving the file to transfer into another software, the file is often called an export, i.e. you can export an IFC from a Revit. For in-depth advice, we do have a Revit IFC manual, which can be followed here. Next, we have an element, which is an item group or type in the model. For instance, a 400 by 400 column. We also have entity or objects. An entity or object is a specific occurrence of an element placed in the model. For instance, you can have one element which is 400 by 400, and then that 400 by 400 element can be placed 10 times. Those 10 instances will be called an object or entity. We also have attributes. Entities carry many attributes which define its shape, specification, material, and other useful things. When exported, model entities carry these attributes so they can be used in other software. Onto the advice. When quantifying a model, it is important to ascertain if the model is designed to be used in this way. Often, models are designed specifically for coordination, meaning they look correct, but may not be detailed enough for other tasks, such as quantity takeoff or engineering. While they can all be used, models that are engineering quality or REBA Stage 3 Plus are often more reliable than early models used for concept. My second advice is, models may not be used exclusively as the contract documents and may not carry important information. Thus,
Models should be cross-referenced with the contract documents, specification and PDF files to confirm it is reliable. In TAS, we help you do this by allowing you to overlay PDFs with the model very easily. Here is an example to demonstrate this. So as you can see, this is a Revit model, open in Revit, and I have drawings relevant to that project as well. Now, if I was to head over to TAS, we have an ability to import the drawings inside this section. Once we do that, we can have the model on the left. We can bring in the drawing. So we have the BIM model, we have the drawing, and we then have an ability to simply overlay the PDF or CAD drawings on top of the model, just so that you can get more context out of it. My third advice is models have many versions. Make sure you're using the latest revision or most up-to-date version of the model. Thirdly, some models may be federated, meaning they may be a mixture of MEP, structural, architectural. It's often better to use the source files rather than a federated model, which can increase noise, objects you just may not want to see. And of course, when you have a lot of information which may not be relevant to you, you're more likely to make errors. So if you can go after source files, go ahead and do that. As you can see in this image, there are two files, of a structural as well as an architectural. So that's what I mean by source files. If you are able to get your hands on them, or you have an ability, just go for the source, go after the model that you need, and then import that. We do have an ability to import architectural, structural, bring them in and federate them if you need to work with both. But ideally, if you can bring in source files, I would recommend working with them. Advice 5 is don't be afraid to use the model if you have it. You don't need to be a designer or have any CAD user experience to extract quantities, as you already have the skills and experience to extract quantities in a meaningful manner. Via TAS and our training, you can import both .rvt and .ifc files directly into TAS. Aside from this, another advice would be, if you can, speak with the designer or model issuer. That can often solve a lot of issues directly, in a similar way to asking for CAD instead of PDF. Often models can be improved if the creator is aware of what you're trying to use them for. If you do have an ability or do have contact or have any sort of interaction, definitely ask for it. It will make your life a lot easier, and you will have a more reliable model onto the common issues. So to help with design, often designers may contain additional flaws for reference or ease. As an example, there may be a single floor which has 3 levels referencing basic floor height, a step change, and the top of the floor build-up. In TAS, it means the quantities of the floors will be split more than they're actually required to. So as you can see here, this is what we'd expect a typical floor to look like. 0, 1, 2, 3, 4, 5. However, you may have additional floors referencing step change and other variables. To get an overall quantity for a single floor, users must combine quantities when connecting the quantities to the bill, i.e. the combined total of floor 1A and 1B would represent floor 1. You can learn how to connect quantities to cost in TAS or via our e-learning. Users can also manually move objects from one floor to another to achieve the same result, but this is only advised when there's a limited number of objects which need to be moved. The second common issue we'll be taking a look at today is export quality. What do we mean by that? Well, when exporting a model from Revit, you need to go through a process of selecting the export settings. However, there is no good quality standard or best practices when doing this. What this means for you is it can drastically affect the model and how elements interact with each other. So how can we deal with it? In order to deal with export quality issues, this is what we recommend. So as discussed before, exports can have varied settings. Therefore, it's advised that designers or exporters follow best practices offered by the design software they're using. In the scenario, Revit. So as a general rule, we recommend you should export via IFC2, coordination view, have split walls, columns by level, all enabled, and export Revit properties, also enabled. Another best practice workflow can be viewed using this section, Kobe Toolkit. It's a schedule generator to ensure all IFC items have the fields completed and data is where it should be. The third common issue we'll be taking a look at today is entity placement. What we mean by this is during the design process, entities can be modeled in the correct position, but belong to the wrong floor. Now, this will affect the quantity output. A common example of this is you may have a core wall which is drawn only on the ground floor. And when you cycle through the following levels, you might find nothing on the first, second, third, and so on. So what this means is if you then go for a floor-by-floor breakdown, you'll find all of the quantities for the core wall on that one floor. Now, aside from the wall example I was giving you, you can see in this example we have staircases that we're taking a look at. So during the design process, items can be placed inside the wrong floor. So although they appear to be on the correct floor, they belong to the floors above or below. In the example below, we can see several floors have been turned off. So floors have been turned off, but you can still see the staircases here. This means that part of a different floor is still visible. And the issue with this is the quantities will all be found again in the, if they were modeled on the ground floor, all of the quantity for the entire staircase will be found only on the ground floor. So of course your total quantity would be correct, but then it won't give you a true or accurate representation for a floor by floor breakdown. You can see the objects are still remaining here. Now, if you ever come across this type of scenario, we would advise you to manually adjust the data, either by splitting the quantities across the floors manually, or contacting the designer to split the object in the correct manner. The next issue we'll be taking a look at is dealing with element types. Element types can be classified incorrectly. For instance, an object may be named or described as a precast floor, but its material or attribute is in situ concrete. So, as I was mentioning before, often elements are created differently for ease of design. In this example, some foundation elements are being shown or seen as slabs. So if I was to just focus on this pad foundation would come through as in situ slab, meaning it would be inside the slab section as well, which is incorrect. Same is true for the piles. This is coming through as a slab as well. So we need to adjust this. Now the adjustment I've done here is I've changed the slab to pad foundation. So pad foundation is in its own category, and same is true for the piles as well. Now the benefit of this is as soon as you do that, it would mean that you're going to be getting the correct measures. So we can check this before import and modify modify in our platform, and it helps split the quantities and make sure the model elements are generating right measures and the materials are correct. So we give you the flexibility to do this. So here another example is this floor, 160 millimeter concrete in cast in place. It's precast, but if I was to then just change the category, I'll just change it to in situ slab, and it will become the correct one. Next, we'll be taking a look at overlaps. Sometimes entities overlap partially or wholly. This can affect the output as quantity may be increased because of it. This also creates model errors and quantity errors. Whenever you run calculations in TAS, we automatically check for overlaps. Sometimes you may find items are on top of each other, either partially or completely. And all of this will be documented for you to just go through. You have sections for whole overlaps, partial overlaps. Issues are displayed here, and all of them are listed as well, along with a basic description and the ID. What we then allow you to do is click on the issues. You then get a view which shows you the error, and all you need to do is delete, for instance, in this one, you can delete the red wall that fully overlaps with another one inside it. So just to give you a live demonstration as well. So again, I have, in this example, I have 158 whole overlaps. And the one I'll be focusing on today is to do with the column, this one here. So if I was to just click on it, I can click on the ID, and can you now see there's this one overlaps with the one inside it. So we then have an ability to click auto process, which automatically tries its best to eliminate the overlap issues, or you can force calculate as well. Now from all of those 158, you just have two which you could remedy yourself. And now the column which was inside this is gone also. Partial overlaps are often minor and can be fixed with the auto process feature as well as whole. So again, I can just show you the partial overlaps. Let's see where they are. And again, I can repeat the same scenario. You can see that there's a partial overlap there. We'll try and remedy this as well using auto process. So those issues have been fixed, and now you only have one to worry about. The next common issue we'll be taking a look at is called custom objects. Many special entities may be created as custom objects. These are items that are unique and carry limited quantity information. For instance, tree or car. So in this example, the custom entities or custom objects that I'm showing are just a couple of trees. This is because some objects that are complex or bespoke in shape may be created as custom entities. This means our software cannot classify them, and as a result, it gets put into a section called custom entity. Now these items generate basic measures such as volume or count. It is advised to speak to the model issuer if you can, if there are any basic custom entities such as walls or doors. Now as an example, with our software, I can show you which section they can come in as. So let's just take a look at this section. We have two things. So I'll hide that. We have custom quantity, and whenever you go to custom quantity, we allow you to count, get a linear meterage, or get an area. Now if I was to count, I can call this whatever. Maybe if I wanted to count the number of trees, I can place a tick over here, and that is one tree, and so on. Now if I wanted to place in a custom element or a custom point, I can again do the same thing, create a custom point, give it a name, enter its attributes, and then I can go ahead and place it in. Next, we'll be taking a look at read-only entities. When exported, some entities may be cut or have their shape affected by other items. Now, this can cause the entity to lose its basic shape, therefore lose its length or direction data used for quantification. You can also think of read-only objects as locked objects, which are normal. It just means you cannot edit them. For instance, you wouldn't be able to change their thickness, length, and so on. Now, inside TAS, because of this, we may not be able to add additional measures, such as formwork, to them. So if I was to just focus here, you can see here is a regular basic wall in which we can enter all of this information, such as thickness, its start elevation, bottom elevation, and so on. However, with a read-only, all of this information is fixed and you cannot change it. Now, if you still wish to edit a read-only object because it's not giving you the measures you need, the only way to do that is by redrawing the read-only object. So you'd have to delete it, create a TAS element, give it the correct attributes, and then draw it in. However, I would only recommend doing this if there are a few instances when this occurs. Now, to demonstrate this live, here's an example. So with us, what you can do is you're able to interrogate your BIM model. You can check how many objects are read-only. So in this one, there's quite a few. Now, if I was to just again focus on this, you can get the element name, its type, the floor it exists, and then the information. So if I was to scroll down, I can see there's line item 270. It's a choose slab, floor concrete deck, tapered insulation. If I was to just double click on this, you can then see this is the item. A lot of the fields are read-only, like the thickness, elevation, and it does, let's see the type of measures it generates as well. So if you also just view quantity, these are the measures that you get. And if I wanted to, let's say, just redraw a section of this, what I would need to do is go into the slab section, then I would have to create an entity. I'll leave it as it is, but you can give the name here, enter the thickness and other information, add that to the name, and then using TAS information, I would be able to just draw this in like so. And then if I was to compare the two, this has information that can be edited, and here is some information. So for instance, I'm only able to change the category here, so a lot of the fields will be locked. The final topic we'll be taking a look at today is using match attributes. What this allows you to do is you can use view attributes to find a section which will be useful for yourself. You can then head over to match attributes to finally find a setting to replace with that. So here I'm using summary info and I'm replacing it with phase created. Now summary info will carry the phase created information like so. So then if I rerun my calculations and update the model, I will then be able to, let's say, go to the beam section, create a new template, and select the slices which I want. So I use summary info. I'll just go to that section and simply turn it on. What that means is now summary info is carrying the data of phase created. Thank you. I hope this has been useful. Bye for now.